A very warm welcome to the class, children. So today's topic is quadrilaterals part 2. We'll be continuing with the practice set 5.1. So the fourth sum says if the ratio of the measures of two adjacent angles of a parallelogram is 1:2, find the measures of all the angles of the parallelogram. Okay, for that we need to first draw the diagram. So this is a parallelogram. Okay, we'll name it as A, B, C and D. So they say adjacent angles of the parallelogram, one is 1x and the other is 2x. So we'll take it this as x degree and this is as 2x degree. That means x is nothing but 1x degree. Okay. So adjacent angles, as we have studied earlier also, their sum is adjacent angles of parallelogram are supplementary. So x degree plus 2x degree is equal to 180 degree, and then we'll find the value of x. With that we'll be able to find out. So whatever the degree of this angle is, that is angle B, would be the same as angle D, because opposite angles of the parallelogram are again congruent. Similarly for angle A, whatever is the degree, that the same degree would be for angle C, as they are again the opposite angles of a parallelogram. So let's solve. So it says solution: the ratio of measures of two adjacent angles of a parallelogram is 1:2. So let the common multiple of the ratio be x. Okay, so then your angle B is equal to x degree and angle A is equal to 2x degree. So it goes as angle A plus angle B is equal to 180 degree. The reason would be adjacent angles of a parallelogram are supplementary. Okay, every time you have to write the reason for the same. So it goes as 2x degree plus x degree is equal to 180 degree. Therefore 3x degree is equal to 180 degree. Therefore x is equal to 180 upon 3, which is equal to 60. Therefore your x, we have got it as 60 degree. So this x we would substitute in this. So now we have got angle B as x degree, that is 60. So this also would become 60, and this would be 2 into 60, that is 120. So your opposite angle C also would be 120 degree. Okay, this opposite angle also would be 120 degree. So let's solve it. So it will go as angle B is equal to angle D is equal to x degree. Opposite angles of a parallelogram. Similarly, your angle C is equal to angle A is equal to 2x degree. The same reason would be given here. Okay, so since your angle B we had taken as x degree, therefore your angle D, that is 60 degree. So angle D also becomes 60 degree. Since again your angle your angle A, I will write it properly. Your angle A is equal to 2x degree, which is 2 into 60, that is 120 degree. So therefore your angle C also would be 120 degree. Okay, your angle C also would be 120 degree. So what is the answer? The angles of a parallelogram are 60 degree, 120 degree, 60 degree and 120 degree. Okay. The fifth sum says diagonals of a parallelogram intersect each other at point O. If AO is 5, BO is 12 and AB is 13, then show that quadrilateral ABC parallelogram ABC is a rhombus. Okay. So let's draw a parallelogram. A, B, C, D. The diagonals bisect each other at point O, wherein AO is 5, BO is 12 and AB is 13. So we need to prove that this parallelogram ABCD is a rhombus. So a parallelogram is a rhombus if its diagonals are perpendicular bisector of each other. So we need to prove that AC is perpendicular to BD. So for that we need to say that angle AOB is 90 degree. So how can we prove that angle AOB is 90 degree? Is that by the help of converse of Pythagoras theorem. That is, the square of the larger side of the triangle is equal to the additions of the remaining, that is addition of the squares of the remaining sides of the triangle. If they are equal, then by converse of Pythagoras theorem we can say that angle AOB is 90 degree. Okay, so let's start. Proof. AO is equal to 5, BO is equal to 12 and AB is equal to 13, that is given. Now we'll check AB square, that is the larger side of the triangle, is equal to 13 square is equal to 169. So AO square plus OB square is equal to 5 square plus 12 square, which is equal to 25 plus 144, which is equal to 169. Okay, so that means AB square is also is equal to 169 and AO square plus OB square also is equal to 169. So by converse of Pythagoras theorem, we can say that angle AOB is equal to 90 degree. Okay, this angle AOB is equal to 90 degree. So in parallelogram ABCD, diagonal AC is perpendicular to diagonal BD, that is from 1, that is we prove that angle AOB is 90 degree. This angle AOB is 90 degree. Also the diagonals AC and BD, they bisect each other. Okay, it is given, bisect each other, which is a property of a parallelogram. Therefore we can say that this parallelogram ABCD is a rhombus, as a parallelogram is a rhombus if its diagonals are perpendicular bisector of each other. If its diagonals are perpendicular bisector of each other, then only we can say that a parallelogram is a rhombus. This is very important. The next sum says in the figure PQRS and in the figure PQRS and ABCR are the two parallelograms. Okay, these two are the parallelograms. P is 120 degree. Then we need to find the measures of ABCR. So they have given us only the measure of one angle, but they have given us that these two are parallelograms. Okay, so if PQRS they have given us a parallelogram, that means therefore SPQ is equal to SRQ. So this is also 110 degree, correct? So when SRQ is 120 degree, your ARC also becomes 110 degree. Why? Because S dash A dash R and R dash C dash Q, they are in the same line. Okay. So now ABCR they have given us a parallelogram. Correct. So ABC is equal to ARC, opposite angles of the parallelogram. So just now we have found out that this is 110 degree. So this also now becomes 110 degree. Okay. Now they say ARC plus your BAR. They are adjacent to each other. ARC and BAR are adjacent to each other. So adjacent angles of the parallelogram are supplementary. So 110 plus your BAR is equal to 180 degree. So you will get to find out the BAR as well. So when you find out BAR, automatically you will find out BCR, because again opposite angles of a parallelogram. Okay, let's solve it, then you will understand it better. So solution: PQRS is a parallelogram that is given. Okay, so therefore angle SPQ is equal to angle SRQ. Why? Opposite angles of a parallelogram. Okay, then angle SRQ is 110 degree, which is obviously given. Therefore you can say that angle S I'm sorry SPQ is 110 degree. So SRQ also becomes 110 degree. Now because of that ARC also becomes 110 degree. So angle ARC is equal to 110 degree. Why? Because S dash A dash R and R dash C dash Q. Okay. Now they have given that ABCR is also a parallelogram. So therefore angle ABC is equal to angle ARC. Again opposite angles of a parallelogram. Okay. Now therefore we can write that your ABC is also 110 degree. Your ABC is also 110 degree, because just now we found out that ARC is 110 degree, opposite angle is ABC, so ABC is also 110 degree. So now we have got our ARC is equal to 110 degree. Similarly, we have proved ABC is also 110 degree. Now, these both are BAR and ARC are supplementary to each other because they are adjacent angles of the parallelogram. Okay, so let's write that angle ARC plus angle BAR is equal to 180 degree. Reason: adjacent angles of a parallelogram are supplementary. Okay, so since we can write now, because of that, since ARC is 110 degree, BAR we need to find out is equal to 180. Therefore angle BAR is equal to 180 minus 110 degree. Therefore angle BAR is equal to 70 degree. So again, since BAR is 70, BCR also would be 70 degree. Why? Because opposite angles of the parallelogram. So angle BCR is equal to angle BAR, opposite angles of a parallelogram. Okay, so BAR we have found out as 70 degree. So BCR angle BAR we have found it as 70 degree. So angle BCR is also 70 degree. So in answer we can write down angle ARC is equal to 110 degree, angle ABC is equal to 110 degree, angle BAR is equal to 70 degree and angle BCR is equal to 70 degree. Okay, so with this we complete the exercise 5.1. Your 7 sum is being reduced, that is it is not there for your portion. The theorem says if pairs of opposite sides of a quadrilateral are congruent, then that quadrilateral is a parallelogram. So given is in quadrilateral PQRS, side PS is congruent to side QR, side PQ is congruent to side SR. We need to prove that quadrilateral PQRS is a parallelogram. So construction is draw diagonal PR. So now we get two triangles, that is triangle SPR and triangle QRP. So in triangle SPR and triangle QRP, side PS is congruent to side QR, it is given. Side SR is congruent to side QP, it is given. Side PR is congruent to side RP, common side. Therefore, triangle SPR is congruent to triangle QRP by side test. Therefore, angle SPR is congruent to triangle QRP by CACT. Similarly, angle PRS is congruent to angle RPQ by CACT. So now they say that angle SPR and angle QRP are alternate angles which are formed by the transversal PR of segment PS and QR. If I have to show you like this, segment PS and segment QR, wherein PR is the transversal. So they say that angle SPR and triangle QRP are alternate angles, isn't it? So with the alternate angles test, we can say that segment PS is parallel to segment QR. Okay. So with that we can say therefore side PS is parallel to side QR, alternate angle test for parallel line. Similarly, angle PRS and angle RPQ are the alternate angles which are formed by the transversal PR of segment PQ and segment SR. So if I have to draw with that, say PQ and SR, wherein PR is the transversal. So in that case, angle PRS is congruent to angle RPQ. That is, again you can see they are forming the alternate angles. So by alternate angle test we can say that therefore side PQ is parallel to side SR, and as we have proved that side PS is parallel to side QR, side PQ is parallel to side SR, and also it is given that side PS is congruent to side QR, side PQ is congruent to side SR. So we can say that quadrilateral PQRS is a parallelogram. The theorem says that if both the pairs of the opposite angles of a quadrilateral are congruent, then it is a parallelogram. Given in quadrilateral EFGH, angle E is congruent to angle G and angle H is congruent to angle F. So I'll write here angle H is congruent to angle F, and quadrilateral E, we have to prove that quadrilateral EFGH is a parallelogram. So proof, let angle E is equal to angle G is equal to X and angle H is equal to angle F is equal to Y. The sum of all the angles of a quadrilateral is 360 degree. So addition of all these angles of the quadrilateral, that is angle E plus angle G plus angle H plus angle F, would be 360 degree. So E is taken as X and H is taken as Y. We are left with G, which is X, and we are left with F, which is Y. So is equal to 360 degree. So therefore X plus Y plus X plus Y is equal to 360 degree. So that is 2X plus 2Y is equal to 360 degree. Therefore we can say when we divide this term by 2 throughout by 2, we get 2. I will take the common 2 common from both these. So you get 2x plus y upon 2 is equal to 360 upon 2. Therefore this 2 and 2 gets cancelled. 360 divided by 2 is 180. Therefore x plus y is equal to 180 degree. Now your angle G is nothing but angle X, your angle H is nothing but angle Y. So angle G plus angle Y is angle G plus angle H is equal to 180 degree. So you can see angle G and H are the interior angles which are formed by the transversal HG of segment HE and segment GF. So by interior angle test of the parallel lines, we can say that side HE is parallel to side GF. Similarly, we can say that angle G plus angle F. Okay, angle G is x degree and angle F is y degree. So x plus y is 180 degree. So angle G plus angle F is equal to 180 degree. Therefore, we can say that side HG is parallel to side EF by the interior angle test for the parallel lines. So from 1 and 2, we can say that quadrilateral EFGH is a parallelogram. Then this theorem you need not prove, but you need to only understand or know what it is. Okay, so if the diagonals of the quadrilateral bisect each other, then it is a parallelogram. So what does it say? If the diagonals of the quadrilateral bisect each other, then it is a parallelogram. That means it's if its segment AE is congruent to segment CE and segment BE is congruent to segment DE, then we can say that this quadrilateral ABCD is a parallelogram. So you need to remember this, that if the diagonals of a quadrilateral bisect each other, that means AE is congruent to CE and BE is congruent to DE is congruent to BE, then we can say that this is a parallelogram. Similarly, one more theorem we need to understand. A quadrilateral is a parallelogram if the pairs of its opposite sides is parallel and congruent. The pairs of its opposite sides is parallel as well as it is congruent. That means segment CB is congruent to segment DA and segment CB is parallel to segment DA, then we can say that it is a parallelogram. That means I'll write down here that if segment CB is congruent to segment DA and segment CB is parallel to segment DA, then we can say that quadrilateral ABCD is a parallelogram. Okay, so you need to not solve the theorem, but yes, you need to know the reasons for it. Okay, let's solve the practice set 5.2. The first sum says in figure 5.22, quadrilateral ABCD is a parallelogram where P and Q are the midpoints of side AB and DC respectively. Then you need to prove that this APCQ is a parallelogram. Okay, so let's see. So again, just now we had done in the theorem that a quadrilateral to be a parallelogram, its pair of opposite side has to be parallel, at the same time it has to be congruent. Okay, so let's try proving that segment AP is congruent to segment CQ, at the same time segment AP is parallel to segment CQ. Okay, so how would we do? Let's see. So proof starts as segment AB is parallel to segment DC. Why? Because opposites. Okay, it's already ABCD is a parallelogram given, so segment AB is parallel to segment DC. So opposite sides of a parallelogram are parallel. Okay, so now that means therefore segment AP is also parallel to segment CQ. The reason being A dash P dash B because they are lying in the same line, and C dash Q dash D. Okay, so therefore we can say that AB is equal to CD. That is because it is given that it is a parallelogram, so opposite sides of a parallelogram are congruent or equal. So we can say half of AB is equal to half of CD, that is CD, because we are multiplying half on both the sides. Okay, so when I say half of AB and half of CD, half of AB means we get AP. Similarly, when I say half of CD means you get CQ, isn't it? So I'll write down here. It will be, if I'm saying half of AB is equal to AP and half of CD will be equal to CQ. Here it would be because P is the midpoint of side AB, and here the reason would be Q is the midpoint. Q is the midpoint of side CD. So therefore we can say that AP is equal to CQ. Correct? So now we have already proved that in the quadrilateral APCQ that segment AP is parallel to segment CQ. Then we have proved just now that segment AP is congruent to segment CQ. So isn't it, just now I said that a quadrilateral is a parallelogram if a pair of opposite sides is parallel and congruent. Okay, so hence we prove that therefore APCQ is a parallelogram. Okay. Next, the next sum says using opposite angle test for a parallelogram, prove that every rectangle is a parallelogram. Okay, so let's see how to do that. We'll draw the diagram first. It goes like this. You have to draw with proper scale and pencil. So they have given that it is a rectangle. So ABCD, when it is a rectangle, they say that obviously all the angles would be equal and that they will be 90 degree. So given ABCD is a rectangle, we need to prove that ABCD is a parallelogram. Okay. Proof: since ABCD is a rectangle, therefore angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degree. Why? Because they are angles of a rectangle. Okay, they are angles of a rectangle. So therefore angle A is equal to angle C and angle B is equal to angle D, because each measures 90 degree. That means each angle measures 90 degree. So for a quadrilateral to be a parallelogram, a quadrilateral is a parallelogram if its opposite angles are congruent. So we have proved that its opposite angles are congruent. Therefore, we can say that ABCD is a parallelogram.